All right, this is 3.4 day or part 1, excuse me, graphs and transformations. Today we are going to be focusing on parent functions and then start looking at what transformations for those look like and then get more into depth on transformations and the transformation function in part 2. So to start with parent functions, we have 11 parent functions here. And parent functions are functions with a certain shape that has the simplest algebraic rule for that shape. So we have these 11, the constant function, identity, or more commonly known as the linear function, absolute value, greatest integer, also known as the round down function, quadratic, cubic, reciprocal, square root, cube root, and then a little less commonly, the reciprocal, squared, and exponential function. So we're going to go through each of these and just talk about the domain, the range, and the asymptotes. So for these first three, I'll explain where the domain and range are coming from, and then as we get to more that have asymptotes, explain where those come from as well. All right, so of your constant function, domain, remember, is any x value that is valid in that function. So for the constant function, any x value can be put into there. So your domain is from negative infinity to infinity. Anytime you see negative infinity to infinity, that interval, we can also shorten that to be the set of all real numbers. And the set of all real numbers is just a capital R, kind of written fancy like that with that double bar right here on the side. The range is a set of y values. So for your constant function, there's only one y value that it can be, and that's going to be whatever you're defining that function to be equal to. So just your constant c value is going to be your range. And then, much like the other ones on this page, this does not have any asymptotes. For the linear, or less commonly called identity function, your linear function, your domain, you can plug any x value into this. Any x value is going to be valid, so all real numbers for that. And then your range is also going to be all real numbers, because when you put any x value in, your output is always going to be a real number as well. And again, no asymptotes on this one. For the absolute value function, your domain, you can put any real number into the domain function as an input. However, your range, remember, you're only going to get outputs that are positive numbers, because absolute value is always positive. So not positive, non-negative. So your range is from 0 to infinity, and you can include 0. Okay, so another way to say this would be non-negative. All right. And again, no asymptotes on this one. All right, so for this one, the greatest integer function, this one's kind of interesting. This one does end up coming up quite a bit. It's kind of fun to play around with this function in math. So what we're looking at is our domain. So what kind of inputs can we have? Well, in this function, you can put any number into it, but your range is a little limited, because what this does is you're only going to have outputs that are integers, because no matter what real number you put into there, you will only be able to get out integers, because you're going to round down. So for example, if you were asked to find f of 5.7, that means you would plug it in and we would say, okay, find the greatest integer that 5.7 could be. You round it down to the integer that's below it. So in this case, f of 5.7 is actually 5. So you're always rounding down to the integer below it. So the only set of outputs you could have are integers. And this Z symbol stands for integers. Okay. And no asymptotes on this one. And then for the quadratic function, this is a common one. We see this one a lot. This one's kind of a fun one to transform because it's easy to see what your transformations are. Your domain is all real numbers. You can input any positive or negative real value into there. But since we're squaring it, we're only going to get non-negative answers. So 0 to infinity, including 0 is your range. And there are no asymptotes here. For cubic function, inputs can be all real numbers. You can put any real number into there, and your outputs will also be any real number, and no asymptotes. All right, so for the reciprocal function, 1 over x. Now, for your domain, your input of x cannot equal 0. So x cannot equal 0 because you can't divide by 0. All right, so we can be any other number. We can be any number less than 0, any number greater than 0. So our domain is negative infinity to 0 and 0 to infinity. You could also write this as x cannot equal 0. Okay. Your range, since that's your y values, that's going to be your outputs. You will never get an output of 0 here because your top number is always 1. The only time with a reciprocal function that you can get 0 is if your top number is 0 and your bottom number is not. So your range is going to be the same thing. Your y value or your output is never going to equal 0. So negative infinity to 0, 0 to infinity. So since x and y cannot equal 0, that means we have asymptotes. So as we draw our graph horizontally, the asymptote, or what the graph looks like or what the graph approaches but never touches, is 0. So x equals 0 is y equals 0 is a horizontal asymptote. And then x equals 0 is a vertical asymptote. Because again, the graph approaches that line but never touches it. All right, then we go on to our square root function. So square root is kind of an interesting one. Your inputs are limited on this one because you cannot plug negative numbers into a square root, right? If you do square root of -2, you get an imaginary number. You get a non-real number, okay? So we can't take square roots of negative numbers, so non-negative numbers for domain. And then your range, your output will end up being the same. You're only going to get positive or 0, so non-negative numbers for your range. No asymptotes on that one. For the cube root function, this one, when you have odd roots, you can have negative numbers. You can have like a cubed root of a negative number. So your domain for this one is going to be all reals, and your range will also be all reals. Inputs and outputs can be both positive and negative for cube root. And again, no asymptotes. All right, and then our last two, reciprocal squared. Your reciprocal squared, so think of your reciprocal, and it's basically just going to make it positive, okay? Because if you square something, it makes it positive. So your domain is going to be somewhat similar, anything but 0. So x cannot equal 0. So negative infinity to 0, 0 to infinity. But now your range is going to be just positive values. So remember, we can't get an output of 0. So only positive, the positive real numbers will be your outputs here, or your range. And then here we have a vertical asymptote of x equals 0 and a horizontal asymptote of y equals 0. So as you can see, this vertical line x equals 0, it approaches on both sides but doesn't touch. And then horizontal asymptote of y equals 0 approaches over here and over here but doesn't touch. All right, and then exponential function. So your domain is all real numbers, so we can basically plug any positive or negative value we want into that. So negative infinity to infinity, all reals. But your range, you're only going to get positive values out of that, even if you put in a negative value. Because if you put in like 2 to the -3, that ends up being 1 over 2 cubed, which is 1/8, right? So you're never going to quite reach that 0, and you're never going to get negative values out. So only positive values are in your range. And then this one, since it doesn't ever reach 0, it's not possible to get 0 here, because if you put 0 in, you get 1. Your asymptote is going to be the horizontal asymptote, y equals 0. right there. All right, so that covers our parent functions. Again, I mean, you will see kind of like these reciprocal, squared, exponential. You will see those once in a while, but these ones, I would say, the previous 9 that we went over are the most common that you will see. And you'll see as we practice the ones that kind of show up the most often. All right, so first we're going to start after we've learned what our parent functions are. We're going to learn to identify these. So take a look at these two and look at your grid in your notes. Which parent functions do these appear to be? So A is going to be a quadratic, and then B will be a linear or identity. Those names are interchangeable. And what you're looking for here is we know A is quadratic, 1, because we've been dealing with a lot of quadratic functions, and 2, we have this x squared here. And we know this part B is going to be linear because it's just x to the first power. Next, think about what our parent functions would be, where these transformed functions came from. And you should see that these are square root. Square root is always a pretty straightforward one. And reciprocal squared. So don't let this 5 out front fool you. You can actually rewrite that to help you out a little bit as 5 times 1 over x squared, like that. So it is the reciprocal squared function. This 5 is just the transformation of it. Next, E and F. And that's going to be your reciprocal and absolute value. People tend to struggle with the reciprocal because they look at it and think, oh my gosh, there's not a 1 on top. Well, remember, you can always rewrite those reciprocals. This can be rewritten as 6 times 1 over x minus 3. That number on top, you're really just multiplying that reciprocal by 6. And then absolute value for f because it has those straight bars around it. All right. What we're going to be heading into in part 2 is looking at the transformations. So transformations come in the form of translations, which are shifts to the left or right or up or down. We also have compressions and stretches, which can be horizontal or vertical. And then we also have reflections. So here's what vertical shifts will look like. If you are moving something up, your addition will be addition. If you're moving something down, it will be subtraction. And vertical shifts will be outside of the function. So if your parent function is x squared, to get a vertical shift up 8, you would add 8 to the whole thing. To move it down 4, you would subtract 4 from the whole function of x squared. All right, and then horizontal shifts, those happen inside the function. So what you're going to do is addition inside the function. If you're moving it to the left, you're going to add something to the inside of the function like this with the squared on the outside. If you're moving to the right, you're going to add a negative or subtract something from the inside there and then square on the outside. All right, and then reflections happen as a negative outside or inside the function. So, for example, this is what a negative outside the function looks like, and we call that a vertical reflection. That is a reflection across the x-axis. So you're either going to, in this case, you're reflecting it down. Okay, so then your line of symmetry is going to be your x-axis there. In the case of a horizontal reflection where you're reflecting it across the y-axis, that's going to be a reflection inside. So this is an example of kind of a combo platter here. So we're moving our function to the right 2 first. So that's what this black function is represented by. And then you reflect it over the y-axis. That's what this negative in front of the x represents. All right, vertical stretches or compressions. In the term of a function, a vertical stretch will be a 3 times the whole function, so 3 times x squared like this. That's a vertical stretch, and you can see if you were to grab either side of this parabola and stretch it upwards, you were to pull each side upwards, it would get skinnier. And then a vertical compression, multiplying on the outside, is going to be multiplying by a fraction like this, so 1/4, a number between 0 and 1 on the outside. And you can see that's like you're pushing those ends down. Horizontal stretches or compressions, those happen inside the function. And they kind of end up seeming like a little bit opposite of what you would think. So if you're multiplying inside the function by 3, you're actually compressing that horizontally by 1/3. And then if you're multiplying by 1/4 here, you're actually stretching it horizontally, stretching it outward by a factor of 4. So that just is kind of a little crash course in those transformations and what that does to the parent functions and how that might look. Now you should have enough information to go and practice 3.4 part 1.